Hey everyone, this is Tiger with one more line of code. We're going to get started today with episode 3 of Riome. Today we're going to work on handlers. We're going to build our first handlers, and we are going to make a couple contracts or primitives of contracts, kind of the early phases of those. I don't know if we'll get through a whole lot more today. We'll just kind of see how it goes as we go through all the explanations and see what I run into. Before I start, though, I noticed on the first videos where I was explaining the architecture, I left out infrastructure and persistence. I want to explain those really quick. So I did remade, I guess, the our chart thing. I had to redraw it because, of course, it had expired. And I've saved this as an image now, so I don't have to keep remaking this every time. But just to gloss over kind of the main line, and then I'll talk about persistence and infrastructure a little more, just so you know what we're going to be doing in the long run here. Web API, if you remember, that's our presentation layer. That's all of our endpoints are there. Anything coming, any requests coming in and requests coming out is all scheduled and maintained and handled under Web API. It doesn't do any work. It's really just, here's a list of our endpoints of what you can kind of access. So it's just presentation, top layer, what everybody can see from the outside in. What it does is it actually sends down a request to the application layer to a handler on the application layer. So this is where we're working today. We'd created some endpoints. Now we're going to work on some handlers. These handlers are really the ones doing the work. They're going to be processing all the data and making it work. However, let me zoom this in a little. These handlers are going to be doing the work. They're going to be scheduling it all out, grabbing, fetching, whatever they need to, and going from there. They will, of course, create contracts to respond with and push them back up to Web API. So API to application to contract and then back up. Domain is our database models and any kind of internal domain type models that we may be using internally as well. But contracts is really what Web API is exposing. With that said, which I sped through that because we already went over those, right? Infrastructure and persistence. Infrastructure is all external services. So anything outside of us where we need to go and fetch data from somebody else's API. These can be, so I guess for Riome, when we need to grab turn-by-turn directions, that's somebody else's API we're going to go get. That data, those connections will exist in infrastructure. When we need to get points of interest, when we need to get data about hotels or, bookings or road, I guess, weather, stuff like that, whatever we end up getting into, right? That would all exist under infrastructure. Anything outside of our control where we need to kind of put these connections somewhere would go in infrastructure. Persistence is our internal connection to data. So instead of where infrastructure is us externally connecting to APIs, persistence is us internally connecting to our own database, our own data sources. So in this project, this will only be our connection to our database. So this will be our database context, and it'll be loading those data. The database tables and models are actually housed in domain, but the actual connection, how to connect, how to fetch, how to query, that all exists under persistence. Domain just stores the model for those tables. So those are persistence and infrastructure. So hopefully that's clear enough for now. Obviously, as we build, it might become a little more clear. So let's get started. Let's start building some handlers, right? Minimize that and let's open up Rider. Riome, obviously. So this is where we ended last time. We had put together these endpoints. We have the two endpoints. So this is just a health check, a success one, and then a health check fail. What we're going to do today is switch these over. Instead of using dependency injection loggers, we're going to use handlers. So where right now we are on Web API endpoints, health checks endpoints, we're right here. This is the file we're looking at. What we're going to be doing is adding handlers into the application layer. So you can pretty much think of this as in Web API, in endpoints. Any folder that I have in endpoints here, I should almost, probably 100%, but just because I can't be certain, in general, Any folders that are in health points should also have a folder existing in application as well. Anytime we have endpoints, there should always be a handler for it, okay? So in application, I will make a health checks folder. Health checks. So now this health checks folder matches with that one, but now of course I'm not going to put endpoints in it, I'm going to be putting handlers in here. So I'm going to make a new class, call it health check handler, and I will make a second class for our health check fail handler. We will start with just the regular one first, and I can make a constructor quick. I'll just make this empty right now, but we're going to use it. And on here will pretty much just be a handle async. Will be a single method. Most handlers in this build will have a single handle method. Sometimes I'll do a secondary or a third, but for the most part, they're all going to have one that I call handle async. I will try to add async for functions that are async. Sometimes I'll forget, but I've learned over time if I add async, then I just always know that it's an async method, etc. Just as you do this a lot, and you come back 6 months later, a year later, 2 years later, you don't remember how you wrote things before. Some little things like just putting an async at the end of it will save you a lot of time later on. What I want to do here in the handle async is pretty much the work that I was doing in the endpoint. So if I come back to the endpoints, and all I'm really doing here is doing this log info on the success, I'm going to cut this out of here, go back to my health check, and pretty much just do that here. Now I need the logger, so I'm going to set that up quick. Make a private read-only iLogger, of course. Health check handler logger. Add the reference for it. And then this, we're getting a little bit more teaching code a little bit here, but this just says that I'm declaring a logger that I'm going to be using, but then in the constructor itself, I need to grab a health check logger from dependency injection. So the bucket of loggers that I have, this will grab one, and then I can assign it to logger. And then, of course, because of underscore, there. Now, this is generally the way to pull from dependency injection and use. You're going to see this a bazillion, million, trillion times. If you ever see me not type this in and it magically pops up, I just want to show this so you guys know. I think Visual Studio has this now, but 5 years ago they didn't. I think it was 5 years ago, and Rider did, which is why I've been using for Rider as long as I have. We had autocomplete, way back then. There were a lot of things. It doesn't matter. I'm getting on a tangent. You see this little yellow under here where it says read-only field logger is never assigned, and I get this little arrow or the light bulb. If I click on the light bulb, I get this option to initialize field from constructor. If I click on that, what you'll see is it automatically did exactly what I had done before. So if you ever see me clicking on the light bulb and all of a sudden something like this pops in, that's all I did. I was just kind of clicking the initialize from constructor buttons to make that pop. I'll usually do it from the mouse with the buttons that you see it happen. But just so you know, I'm not super typing or hitting some crazy scripts or whatever. I'm tapping that stuff that already exists. Cool. So this handle async is going to run the same logger, and then let's return something here. We'll just return a Boolean for now. We'll return true on the success one. We'll return false on the failure one. I don't like returning generic things like this, like a string or a bool. I want to return an actual result object type, but we'll get into that next. The only other thing I'm going to do here right away is I'm going to mark this as sealed class. I don't know if I talked about sealed before or not. Sealed just means you can't inherit from a class. So if I did something where I had another class, okay, somewhere else in code, not here, but just for the sake of this, if I had a class, foo, and I wanted to inherit health check handler, as you can see, I'm getting a red, and if I hover over this, it says you cannot inherit from a sealed class. That's all sealed means. You cannot inherit from it. Because you can't inherit from it, there's less overhead to the class, to the setup of the class, and some more recent stuff has shown me that it looks like that could potentially increase your request throughput. It's a very, very quick, small, easy way to potentially increase some request throughput by reducing just a little bit of overhead. So when you see me adding sealed all over the place, this is usually why. If I want to inherit from it, all I got to do is remove sealed and it'll pop up. Well, if I had an empty, it's giving me an error because I don't have an empty, but you see it's all happy now. Okay. So this would work just by removing the sealed. Now, I don't want anybody to ever inherit it from any of my handlers, so all of my handlers are going to be sealed. Let's backtrack. Perfect. So public sealed health check handler. I'm just doing the same log. Super simple. I'm going to copy this to the health check fail handler because it's almost identical. And instead of log info, I'm going to log a warning and mark this as a failure. And then, of course, we need to return false. Let's add this reference. Cool. Now I have the two handlers, which is wonderful. Let me go back to endpoints. I have two health check handlers. I need to change the endpoints to use them. So I'm going to get rid of this iLogger thing. And now I want to use the health check handler. Of course, I'll need to import the reference. And now my result is going to be handler handle async. I'm getting a red here because I didn't mark this function as an async function, which is what's happening there. This is called minimal APIs. I don't know if it's super old or it's not old. It's fairly new. I guess I never really explained it, but I think there's tons of tutorials on it. You'll be able to find out all about it. I like the pattern, so we're going to continue with it here. Anyways, if result was success, we'll then return our success. Otherwise, we're going to return something like a autocomplete. Yep, like a bad request fail. And I can pretty much do the same thing for our fail thing, except I need to grab the health check fail handler. And again, I need to add async here, but just so you can see the error message, the await expression can only be used in a method or lambda marked with the async modifier. Can't use async when you're not async. That's fairly straightforward error. Now we know that this handle async from the fail one is going to return false, so we know it's always going to drop down here. So this is literally what I need. Now I'm going to run this, but I know it's going to break because we have not registered the handlers into dependency injection. I'm going to show you how to do that really quick, but then I'm going to comment it out. So normally in application in dependency injection, what I would do is we'd come in here and we would have to register the handlers. So health check handler and scoped health check fail handler. This registers them to dependency injection. I don't want to do that right now because I want you to see the error that happens because it's a funny worded one. And it's caught me a few times, and I'm almost certain that as we go through this, I'll probably forget at some point. So I want to run these with the fail happening so that we can show you what happens here. Basically, I'm trying to create a problem. So this will run. Everything compiled, everything ran, the whole app started up. So even though these are not registered, everything started up. We don't have an error. You'd be able to publish this to production and nobody would know yet. Here's where the problem would come in. I'm going to open up Postman and see if I zoom in. Yeah, I think you can see that. Maybe get my head out of there a little. So if I run this health check, I should explode. And of course I do. Now we can read the error message here, but I'm going to go back down into Rider and show you. So unhandled exception, invalid operation exception, the error message says body was inferred, but the method does not allow inferred body parameters. The parameter is handler, the source is body inferred. What the hell does that even mean, right? It's a really weird, funky body infer invalid op goofy little thing, right? Here's what's happening. Health check handler on these minimal APIs, it doesn't know where the heck to grab handler from. It doesn't know if this is supposed to come from parameters, from like a query parameter, from the body of the request, from dependency injection services, or from somewhere, from like a form or whatever the heck it's getting posted. So you can declare where you want it to come from. And if we scroll down in this exception a little bit, you'll see actually the little helper text. Did you mean to register the body inferred parameters as a service, or apply from services or from body attribute? If we apply from services, because this should be coming from services, which is what it suggests, this is still going to fail, but it's going to fail smarter. I want to run this to show you how this is going to fail. But I want to comment out this other one first. The problem is if I have them both in here and I try to run this, we're still going to get the same error because this one exists. I'm cleaning it up so you can see the errors better. So what I did is I'm adding from services to say that this health check handler should come from dependency injection services. The other options are like from form, from query, body, I believe. And then for like a get request like this, where you normally wouldn't even have a body, I think you can do some like add parameters things, which would take this model and read it as if they were parameters. But we're going to say from services on this one. We'll go through, we'll have to use some of the other ones, but let's say from services. I'm going to run this again. The reason being, because it doesn't know where it was coming from, it infers or guesses or assumes that it's coming from the body, and it's not allowed to get anything from the body on that get, and there's nothing coming from the body on the get, so it throws a whole wrench into the system, and that's where the exception comes. But that's why it's this body inferred, weirdly worded message. So if I run this now with our from services on here, I'll leave that there, but you can see I still get an invalid operation exception. But now I get a no service for type health check handler has been registered. That to me is a little bit more clear. Like, hey, you have a health check handler from services that isn't registered. So something's wrong with our service registration. So I'm going to stop this, go back to our dependency injection on application, and register those services. Now I can run this. Go back to Postman, hit run again, and you'll see if I zoom in especially, we get our success again and we're getting our 200 OK. And now we know that we're actually going through and hitting our handler and getting our success and true back, which is what we've been looking for, which is great. The only other thing I want to do now, if I go back to these endpoints, I'm going to take out this from services. I'm going to go ahead and uncomment the fail one as well so we can test it. I'm taking out from services. You might expect that this is going to give me some crap about body inferred error again. It won't. It does try to search around to locate these beforehand. Because I have this health check handler registered in DI now, in dependency injection and services, it will be able to locate it and it will know that that's what I'm trying to use. So I don't have to declare this is coming from services. It knows this is coming from services because we have it properly registered now. Let's run it just to test and we'll check the fail one as well. That started. Let's go to Postman. Were you guys able to see what I'd done before? Hopefully. Yeah. I forgot to zoom out, but I think you saw what the important stuff. So if I run this health check, you can see I still get a success. If I run the fail, you can see I still get a fail and a 400 bad request. Everybody's happy. Cool. Well, let's continue. All right, we have our endpoint set up. The only other thing that I don't like about this, I like how the way that this is set up, but as I mentioned earlier, our handler is responding with a Boolean. And I don't necessarily like that I'm responding with a Boolean. I want to respond with like a generic response type object or an error object. or preferably something that handles both scenarios, which is what I'm going to do. Let's go ahead and just get those set up. In contract, because as you remember, we should always be creating a contract and giving it back. In contract, I'm going to be creating what I call primitive contracts. These are just the core, everything kind of spawns from these. We'll have a bunch of kind of one-off contracts for a lot of the handlers, but right now I'm going to create the result contracts and error contracts that we're going to use everywhere. So in contract, I need to add a folder or a directory. We'll call it common. In common, I'm going to add another directory called primitives. And I will make some classes. One of them called error. One of them called result. One of them called result t, and that's it. In my error class, I'm going to seal this, and I'm going to create a code with a private setter and a message, again with a private setter. Private set because I do not want errors to change. Once an error is created with a code and a message on it, I don't want somebody to be able to kind of update the codes or messages or change them along the path back up to the web API. So I want everything locked down. You'll see me doing a lot of private setters just in order to control the flow of data a lot, and this is one of those cases. Of course, in order to set those, I need a public constructor that takes them. So I'm going to make one, which looks like that. Autocomplete fixed, or I guess helped out a little there. Pretty simple. I'm pretty sure you can figure out how that goes. In theory, I could make these nullable, but I don't want to. But I am going to make like a quick helper. I'm going to make a static function called error, called none, that returns a new error of type of string empty empty. Yeah. So I don't care so much about responding with a null error. If there's no error, I have two options. I can return with a null, or I can return with kind of just like an empty error object. In this scenario, I'm going to go to the option of returning with an empty error object. It's not really empty, it's just it has an empty code and an empty message. Reason being that the front-end teams that I tend to work with, I don't know what it is, but null is like the worst possible thing in the world for them. I don't know what the big deal is, maybe because of my C# background or whatever, but they just don't like checking for nulls. Most of the times they would much rather have an empty object or an empty array as opposed to a null. So I've gotten in the habit of always trying to respond with at least an empty something rather than a null. This is one of those cases. We'll always respond with an error. It just may have empty strings instead of nulls. Okay, let's take a look at our result object. I can't seal this one because it's going to be inherited by result t. But the result object's pretty simple. I'm just going to have an is success and an error. This is that scenario that I just kind of briefly touched on where I could theoretically make this a nullable error and pass null back here, assuming is success is true, error would be null. But it's that scenario where for some reason the front-end teams don't really like that. So I'm going to force that always some error exists. Again, I need a constructor to pass those. Autocomplete, save me. Yep, perfect. And I do want to make some kind of quick, versions of this. So I'm going to make a public static results. That's mostly correct. So like result.success would give me a new result passing is success true and an error none, which is what I want. But I'll explain in a minute why I'm not super happy with this just yet. Look at autocomplete go. Good job. I'm going to make a failure also. Let's just plop that in there. I'm going to make a failure which takes an error and passes false for a success and the error itself. Cool. This one I like. A success one I don't. Here's why. If I'm returning, I want consistency, okay? So if I'm returning something like a, let me make just two functions here quick. If I do returning a result object and it's like foo and like a foo2, okay? Just, I need something to show. If I'm returning success right now, I would return result success. If I'm returning failure, I need to make this a 2, foo2, that's fine. We don't care about spelling at this point. This would really be more of a like a code and a message. Okay. I'm assuming you can see this with the color change, but basically like success is blue, failure is green. Seems like a dumb, why the hell would I care about the color, right? The thing is, I want anybody coming into here to understand the pattern of how I've kind of created these primitives. They're used everywhere. So doing these correctly and making sure that the pattern is, I don't know, what's the word, cohesive, similar, it matches all the time so that anybody guessing could guess what to do. What I don't like about the success is that it's not a function. Failure is a function, you know, taking an error. I want success to also be a function. So all I got to do here, if you want, I'm just going to turn this into a function. And now I switch this to where it's a success function. Now you can see they're both green. And even if you lay them up kind of side by side each other, well, I mean, if I had coloring, right? Which I don't, but the way that they work, I think is far easier for most devs just to pick up like, oh, obviously, you know, everything, you know, is success function, failure function, whatever. I think it just makes it a little more clear in the long run, where if I have some random little parameter grab, I don't know what these are called, but it's not running the function to generate it. It's just a get. I don't know what it's called, but I don't like this as much for this case because I want the two equal. I want them running the same way. It's a silly tangent, but it's for later, okay? Let me add my method stuff back in there. So I think this looks good. We'll continue with this for now. Result T is the next one I need to work on, which is going to inherit from result. About the only thing special about this is it's going to take a T data field, and instead of result, it's actually result T. I just can't make a file name like that. And I'm getting a red error right away because I don't have a constructor that matches result. I don't need one that matches it, I just need one that calls it because there's no empty constructor. So I'm going to make a constructor which takes, I want T nullable. Actually, I don't need that, I need this. Where I take a nullable data, and then of course I'll take the usual is success and error of the same way that I would with the base, with just the result base. I don't need result. I don't need this T here. That's what it's giving me crap for. Is success and error. There. And then of course I got to set data to data. Generics can get a little bit goofy, and this one I usually have to think about and fiddle with over time, so I may change this, but off the top of my head, this looks about right. What this will be is a result object that has is success, error, and a data object, so that I can kind of pass a result of whatever type. Result of user contract, result of cart contract, result of foo contract, right? Without needing to kind of create result objects of each one. But now all consumers of the API always know it comes in the format of this result object, right? So that's what I want. I do want to make quick helpers for this version as well, where I want a success of a typed one and I want a failure of a typed one. But I'm going to put them on the result class, not this result T. This is about all that'll ever be in this result T. So let me go back to result. And I'm basically going to clone these. Let me just make a second copy of them. What I'm going to do, we'll start with one at a time here. I'm going to write this up and then we'll just kind of talk through it. It's going to return a result of type T. It's giving me red right now because it doesn't know what T is. I need to declare what T is right here. And then, of course, instead of passing a blank result, I need to pass a result T type. We know the constructor of that takes 3 fields. So what I need to do is pass the data object, which in theory I have right here. Okay, so on a typed success, I'm passing the data object. So result dot like a result user contract, right? I would always do result dot success pass the contract. So this works out perfect for that one. The failure is a little bit more complicated. Not complicated, it's differenty. So in the failure, I again need to return a result t. I need to declare what type this is going to be here so it understands. But on a failure, I'm not going to have a data object to send to it. So if I'm failing, I don't want to send a data. There are potentially times where you might say fail but still respond with a contract, like update this user, right? You may want to say that failed, here's the current copy of the user contract. I'm not going to allow that in this API. In this API, a failure is a failure. If you want to figure out what state it's in, call it again, okay? So in this sense, I'm not going to need a data here. What I do need to change though, outside of declaring a result t, I'm going to be taking in something for data because I need to set something there. It's a nullable generic field. So in theory, we could put a null here. But as you can see, I'm getting red. If I hover over this, you'll see that argument type null is not assignable to parameter type t nullable, which blows my mind that nullable t cannot be null, but whatever the hell, right? This is coding awesomeness. I can cheat this a couple different ways, but we'll show you the right one after I break with it a bit. If I go into this, result t, I can do a couple things. I can try. This isn't going to work, but I can say where t is a class, class as a specific thing that can be nullable now. So now it knows a t nullable should be able to be set null. If we go back to result, you can see it's mad at me here, not just at null, but also here in t, because it must be a reference type in order to be used like this, right? So it gets weird here. I could try doing things like where t is a struct, okay? And out here, now all of a sudden, hey, I can pass null, because struct can be a null, but I still can't use it as a generic object because type t must be a non-nullable value type in order to use it as parameter t, okay? And even my success is failing now. So I don't need any of this where stuff. The trick, which isn't a super complicated one, all values in C# have a default value. If I'm not passing anything, in this scenario, I'm always going to be using classes, so I know this can be null, but it won't let me pass null. All I need to do here is say use whatever the default value is for this generic, and you can see all my red errors go away. Over here in result t, everybody's still happy and excited and wonderful and living the dream, right? I do need to seal this. I don't need to, but I'm going to. But you can see this is all working perfectly fine. Everybody's happy here just by passing default instead of null. This is going to be null, but I have to set it as default. Okay? Let's take a look at what this would look like. So these are the generic objects, the three of them, the primitives. Let's go put these onto the handlers to see how this is going to work. So if I jump over to application health checks, we'll go to our normal handler. I don't want to respond with a Boolean anymore. I want to respond with a result. I need to import, of course, and respond with result success. Everything seems happy there. Let's go to the fail. I want to respond with a result, of course. And we're going to respond with a results failure here. Now, on a failure, I need to pass an error of some type. So let's make like a health check. We'll just make a fake code and a fake message, right? Health check failed. And respond that way. If I wanted to do the generic, okay? We're not going to keep this. This is just to show you a generic version. If I had some generic class, okay? Test foo, public string foo. So I have this generic test class, and instead of responding with a result, I want to respond with a result of test foo. I have a couple things I can do here. So let's assume success. Okay, so foo would be perfect. It auto-completed. That's awesome. So even autocomplete picks this up. I would return result.success passing in test class. I didn't need to type this in any way because, it knows that this is test class and it's responding appropriately. So it's still really easy to respond with a success on a typed one. On a fail, I wouldn't have this foo. I'd be responding with a failure. And of course, well, a new error message, right? Let me just undo this one. I'd be responding more similar to this, but I still need to tell this that this needs to be a foo object. Right now, it's just responding with a result object, not a result t. So all I need to do is tell this you are of type test foo, and everything is happy. So everywhere else in code, we're going to be using this for failures, and of course the success or success passing the object. So let's get rid of this. I've got my new handlers. They're responding with result objects. Let's go to our endpoints and fix them. These were taking booleans before, but if you remember now, I'm taking result objects. So all I need to do is say if result is success. If result is success. I do want to also respond with the result object itself. I don't want to do these hard-coded strings anymore on the response. Now we're responding with the results. So we've effectively gotten a web API to take in an endpoint, pass it off to a handler, generate a result contract, and give it back out. Let's test. That's starting. Let's get Postman up. Zoom that bad boy in. Go to our original health check, and if I fire this one along, you can see that now I get our is success true and an empty error message. Okay, still 200. A fail check still gives me 400, but now you see is success is false, and I get an error message with a code and a message in it, which is perfect. And of course, if we had generics going, we would have gotten a data thing with some, some object in it or a null. Okay, so love it. Let's see, I want to make one more change quick, just to the result object itself, because one of the things I've run into is responding with an error is nice, but there's a lot of times where I need more than one error. Like take validation, for example. It's if you need to send me a password that's more than 6 characters and a first name and a valid email, right? And you didn't do all 3. You could fail at the first one and respond, which is fine. It's efficient. It works. But there are times where it's nice to kind of say, here's the 3 things you did wrong on this request. You missed the first name and the password length and the whatever, respond with all 3 errors. It's one small example, but it'll probably crop up in a few different places. So I'm going to switch the error on the result to a list of errors. And then we'll make some slight modifications to handle that. So I'm going to duplicate our constructor in the result and take an IEnumerable of errors, of error, called errors, and set errors. Because I'm doing an IEnumerable, I do need to to-list this. But this lets me pass an array or whatever the heck I want to it. It gives me a little bit more flexibility. This needs to be errors. So I don't want to get rid of the single error one. I'm just going to put that as the single item in the array. So all I need to do here is make this the single item in the array. I don't know how common this is. This little square brackety thing, this is shorthand for this. That makes sense. This, just dropping it in the array like this is shorthand for create a new one of this. Okay. So when you see me doing that, that's not some big black magic voodoo craziness. That's just, shorthand. And I take enumerable errors now, so I need to adjust my two failure ones to also take, a potential list of errors. And I need to update my generic one to also take enumerable of errors, and that should work. I'm getting red here, of course, because I need to go and update the result t class in order to handle this the same way. So let's jump over and do that. All I need is a new constructor, same way as we did on the regular one, to take an IEnumerable of errors, and of course pass the errors up. There, that's it. No other changes here. Back on result, my red went away, and we're all happy again. Alrighty, let me go back to, I don't need to make any changes to the handler. Result success still works, fail still works, everything all still works, even our endpoints, no changes here. We'll run this again just to show you the change that we've made. And then I think this will be pretty good for today. We'll just kind of leave it where it is. Let's do one little last test. So our regular health check, zoom in again. I'm going to run a send. And you see the only thing that changed is now the arrays, or errors, sorry, is coming in an array. Now it's still an empty item here. And here's a scenario where maybe we could do an empty array of errors instead. I'm not going to do that. But it's something to think of here where you may want to just respond with an empty array in this scenario where there's no error. The fail, however, again, splits to an array with the one error message in it, but now we could have 5, 10, a million error messages in here, right? So we get a little bit more flexibility along the way. So I think we're good for today, because really what we have, we added our first endpoints, or we already had our endpoints. We added our handlers, we hooked everything all up to them, and we generated our first primitives. So we've actually accomplished quite a lot of stuff here. And I think I want to start getting into a little bit more of the database line to start creating user accounts and start getting down the authentication and login type stuff. Now that we have, handlers and endpoints, I can make login endpoints and login handlers. So in order to start storing data, we're going to start going down the database path next. So stay tuned for that. Thanks for watching. We'll see you guys on the next one.